Today, we are going to discuss about the topic the enzyme inhibition. Before dealing with the enzyme inhibition, we need to tell about the enzymes. Enzymes are the biocatalysts that increase the rate of a reaction. Coming to the enzyme inhibition, we all know enzymes are the biocatalysts that increase the rate of a reaction. Coming to the enzyme inhibition, this enzyme inhibition is a phenomena where the inhibitor will be acting on the enzymes where the inhibition will be taking place. And these inhibitors play a vital role in regulating the different type of various metabolic pathways such as cellular balance, etc. And coming to the enzyme inhibitors, these enzyme inhibitors may be inorganic or organic in nature, and they will be drugs, antibiotics, toxins, and antibiotics. And these enzyme inhibitors is may be classified into organic or inorganic, and these inhibitors is drugs, antibiotics, toxins, etc. Now coming to the classification, before dealing with the classification, we can move toward the enzymes reaction. Here in the first reaction, that is the F figure, we can see the normal reaction. Here the enzyme is binding with the substrate where the enzyme and substrate bind toward the active site for the enzyme substrate complex. After that, we can see in the last reaction here the product is released. At first, the substrate is binding with the enzyme for the formation of the enzyme substrate complex. After the formation of the enzyme substrate complex, the results such as the products are released. Coming to the second slide, that is second reaction, that is the inhibitors. Or with the presence of the inhibitors, the inhibitor is binding to the active site of the enzyme where the enzyme binds with the inhibitor for the reaction to stop. In the last figure, we can see there is no product is released. Therefore, this reaction represents the enzyme inhibition where the enzyme bind with the inhibitor for the formation of the enzyme inhibitor complex. When we are comparing with the both figures of both reaction, in first reaction we can see the results, that is the product are released, whereas in the second reaction, due to the presence of the inhibitor, the reaction is never taking place or the product are never released. Now we are going to discuss about the different classes of enzyme inhibition. Normally the enzyme inhibitors are classified into two, and they are reversible inhibition and irreversible inhibition. Coming to the first one, that is a reversible inhibition. From the name itself, the reversible, that is the reverse back, and it is a temporary process. Actual as in temporary process means it is a temporary and can be reversed. Coming to the second one, it is irreversible. Irreversible means it is a permanent process after when the substrate bind to the enzyme, or in case of inhibitors, in case of substrate, inhibitors are binding with the enzyme. These inhibitors bind with the enzyme for the formation of the enzyme inhibitor complex. In case of the reversible inhibitors, whenever the inhibitor is released from that particular reaction, the enzymes or the reaction is taking place by the binding of substrate toward the enzyme. Coming to the second one, that is the irreversible reaction. In irreversible reaction, the enzyme or the inhibitor bind with the enzyme's active sites for the formation of the enzyme inhibitor complex, and that will become a permanent process, or it will alter all the functional of that particular enzymes. And after that, whenever that particular inhibitor is released from the irreversible reaction or from the enzyme, the reaction will be never happening because all the functional molecules or functional characterization of the enzyme is lost. Now we are going to discuss in detail about these different type of enzyme inhibition. Coming to first one here, in case of enzyme inhibition is a phenomena, whereas enzyme inhibitor is a molecule where the enzyme's reaction is taking place for inhibitor reaction. The first one, the enzyme inhibitors are classified, and we already told that they are classified into two. They are reversible inhibitors and irreversible inhibitors. And coming to the reversible inhibitors, they are classified into three. They are competitive inhibitors, non-competitive inhibitors, and uncompetitive inhibitors. Coming to the reversible inhibitors, they are classified into two. They are suicide inhibitors and group-specific inhibitors. Once more, I will tell. Enzyme inhibitors are classified into two. They are reversible inhibitors and irreversible inhibitors. And these reversible inhibitors are classified into three. They are competitive inhibitors, uncompetitive inhibitors, and non-competitive inhibitors. And in case of reversible inhibitors, they are classified into two. They are suicide inhibitors and group-specific inhibitors. But first, we can we can deal with the reversible inhibition. We already told that reversible inhibition is a reversible process. That means it is a temporary process. That means whenever that particular inhibitor is bind to that particular enzymes, the reaction gets stopped there. But after that, when we are removing that particular inhibitor from that particular inhibitor, the reaction will be taking place and the product is released, and it is a non-covalent bond. That is, the binding of inhibitor toward that particular enzyme is a non-covalent bond. That is a weak form of interaction. That is why we are telling it is a temporary process. Coming to their classes, we already taught, and once more we can tell, that is, they are classified into competitive inhibition, uncompetitive inhibition, and non-competitive inhibition. Now we are going to discuss about how we are in dealing with the different type of reversible inhibition. And the first one is competitive inhibition. Coming to the name itself, the competitive inhibition means there is a competition between the inhibitor and substrate toward the enzyme. Competitive means competition between the substrate and inhibitor. We already know that the substrate is the main thing that is binding on the active site of the enzyme. But in case of competitive inhibition, in case of substrate, it is removed from that particular enzyme and the inhibitor is taking place and binding to that particular enzyme. Therefore, in case of the competitive inhibition, this particular substrate and inhibitor is having a particular analogous. That is, the inhibitor is structurally analogous towards the substrate. Therefore, competitive means there is a competition between the substrate for binding to the enzyme's active sites. But first, the substrate is binding to the enzyme's active site and the reaction is taking place. Whenever we are adding the inhibitor toward that particular reactions, what will happen means the inhibitor is having the same structural analogous toward the substrate. Therefore, these substrate molecules are removed from that particular enzyme. The inhibitor is again binding with that particular enzyme for the reaction to stop the. Here we are all discussing about the enzyme inhibition. Therefore, whenever that particular inhibitor is binding with the enzyme, the reaction will be stopped there. And the inhibitor effect of the competitive inhibitors can be overcome or can be reduced, removed by we are adding more and more substrate. If whenever whenever we need to remove that particular inhibitor from that reaction, we want to add more and more substrate. Therefore, the substrate will be binding with that particular enzyme's active site and the reaction will be proceeding by the product formation. And this is all about the competitive inhibition. Once more we can deal with the reaction. Here we can see the enzyme. This is a normal reaction where the enzyme is reacted or the substrate is binding with the enzyme for the formation of enzyme substrate complex, and the product is released after formation of the enzyme and substrate. The product is released in the first reaction, but when we are adding the inhibitor, here the inhibitor is the competitive inhibitor. Whenever the inhibitor is binding with the enzyme, the reaction is never taking place, and this is about the competitive inhibition. Once more in competitive inhibition, we need to tell that the substrate and inhibitor are analogous. Coming to the next inhibition, that is non-competitive inhibition. Here, there is no competition between the substrate and inhibitor, but the inhibitor is binding to the site other than active site, that is known as allosteric site. Therefore, in case of the non-competitive inhibition, the inhibitor is binding with the other side other than active site, that is known as the allosteric site. That is why they are not having a competition between the substrate and inhibitor. The presence of the substrate does not influence the binding of non-competitive inhibition. In case of the competitive inhibition that we have already discussed, when we are adding more and more substrate toward that particular system, the reaction is taking place. But in case of non-competitive inhibition, will never happen. There is no link or there is no relation between the substrate molecules with the inhibitor molecule. That is one of the main criteria or the main characteristics of the non-competitive inhibition. Therefore, here, whenever we are increasing the substrate constant, it will never alter the reaction between the enzyme and inhibitor. But this non-competitive inhibition is an inhibition that is coming under reversible inhibition. Therefore, can be reversed back. That is, the reaction for need to be taking place. Therefore, that the inhibitor is removed from the allosteric side by other methods, and this is all about the non-competitive inhibition. Coming to their reaction or their structure, here this is a normal reaction, that is the competitive inhibition. Here first one is a non-competitive inhibition where the enzyme substrate is here. This is the active side, but in non-competitive inhibition, this is the allosteric side where the substrate is binding with the allosteric side. This is the active side of the enzyme, but active side is not the side where the inhibitor is binding, that is the allosteric side. The substrate will be binding or inhibitor will be binding to the other side other than active side, that is known as the allosteric side. Whenever that particular inhibitor binds with the reaction is never taking place. Now coming to the uncompetitive inhibition, here also it is almost same that of the non-competitive inhibition where the inhibitor is binding to the allosteric side, but one of the main criteria or the main difference or main peculiarity of this reaction is that binding occurs exclusively with the enzyme substrate complex, that is, the allosteric site of the enzyme substrate complex is the site where the uncompetitive inhibitors can be binding. Whereas in case of the before we have already discussed about the non-competitive inhibition. In case of non-competitive inhibition, the inhibitor can bind with both the free enzyme as well as the enzyme substrate complex. But in case of uncompetitive inhibition, the inhibitor can bind only with the enzyme substrate complex allosteric side. That is one of the main specification of the uncompetitive inhibition. Now we are moving toward the reaction. Here the first one represent the enzyme and substrate. In case of uncompetitive inhibition, enzyme is binding with the substrate for the formation of the enzyme substrate complex. After that, the inhibitor is binding with that particular complex. That is, in case of uncompetitive inhibition, the inhibitor will be binding with the allosteric site of enzyme substrate complex, and the reaction is stopped there. Now coming to the other reaction, that is irreversible inhibition. But first we have discussed about the reversible inhibition, and there are three classes of the reversible inhibition. They are competitive, non-competitive and uncompetitive, that we have already discussed. Now we are moving to the irreversible inhibition. Here the irreversible inhibition is a permanent process where whenever the inhibitor binding toward that particular enzyme, the reaction is stopped there. After removing that particular inhibition, they can never form the product because all the functional form or functional property of that particular enzyme is damaged or destructed by the reaction of that particular inhibitor with that particular enzyme. Therefore, it refers to the cessation. Cessation means stopping of enzymatic activity resulting from permanent structural changes induced by that particular inhibitors, and after binding, it will destruct all the functional properties of that particular enzyme. And unlike reversible inhibition, it can be never reversed. That we already discussed that reversible inhibition is reversed, whereas reversible inhibition is never reversed. And coming to their classes, they are classified into two. They are suicide inhibition and group specific inhibition. That means the irreversible inhibition is a permanent process where they are classified into suicide inhibition and group specific inhibition. Coming to the suicide inhibition, it is also known as the mechanism based inhibition. From the name itself, suicide, that means through a pathway. When we have already know about metabolic pathway, in between the metabolic pathway, whenever the A converter to B converter to C converter to D, and the last product, that is the end product of that particular pathway, will be converted to a particular toxin compound, and it will inhibit that particular pathway in the first reaction. That means that particular inhibitor, that is a metabolic pathways compound, will be converted to a toxin compound. That is why it is known as the suicide inhibition. It is typically a structural analog or competitive inhibitor. Actually, this suicide inhibition is almost similar to competitive inhibition, that is structurally analogous toward the substrate, but they are reversible. That means they are irreversible. And coming to group specific inhibition, that is the other classes of irreversible inhibition. Coming to group specific inhibition, from the group specific, from the name itself, it needs, or it tells that the inhibitor reacts only to certain functional group. For example, coming to DIPF, that is a product, that is a compound mainly found in the insecticides. That DIPS will be binding with the amino acids contain the active serine residue. We all know about the amino acids such as serine, histidine, etc. That is mainly present in the active site of the enzyme. Whenever we are adding the DIPF, these DIPS will be binding with the enzyme's active site where there are large number of serine residues. Coming to the iodoacetate, which is having an active thiol residue, histidine residue, etc. That means this iodoacetate will be binding with the active sites with high amount of thiol and histidine residue. And last one example is iodoacetamide with active cysteine residue. Okay, this is all about the inhibition, that is enzyme inhibition. I will repeat once more. Enzyme inhibition is classified into two. They are reversible inhibition and irreversible inhibition, and this reversible inhibition is again classified into three types. They are competitive, uncompetitive and non-competitive, and whereas irreversible inhibition is classified into group specific and suicide inhibition. In this class we have already discussed about all the different mechanism of this enzyme inhibitors towards a particular enzyme. Okay, thank you.